So we're looking at the same graph. What's the initial height of the ball? I know that initial height, I learned this in 8th and 9th grade, that initial height means y-intercept, right? So it's another fancy way of saying y-intercept. So the initial height of the ball is going to be wherever the graph or parabola, right? This is a parabola. That's what this shape is called. Touches the y-axis, so it touches it at 1, which is the height, right? So the initial height of the ball is 1 meter. And that's what your answer should have been. What is the coordinate pair that represents the ball before it's thrown? So again, that's another fancy way of saying what's the height of the ball before it's thrown, but write it as a coordinate pair. So how can you write that point as a coordinate pair? Well, we know that a coordinate pair puts x first and then y. So when we look at this point, we have to ask ourselves, what is the x value? Well, x lines up with 0, which makes sense because it hasn't been thrown yet, and y is at 1. How far will the ball travel horizontally before it hits the ground? So hitting the ground would look like the height of the ball being 0, right? So if it hits the ground, that means it would be 0. So we're looking at where does the graph touch the x-axis, or where is an x-intercept? So the ball would be here when it hits the ground, right? Because the height of the ball is 0. And if the height of the ball is 0, that means it's on the ground. So it would be about 8.5 meters before it hits the ground. That's how far it travels. What is the coordinate pair that represents the ball when it hits the ground? So again, write this now as a coordinate pair. Well, we know it's x and y, right? Well, our x value we already know is 8.5 meters. And our y value lines up with 0. So you'll notice with intercepts, one of the coordinates is always 0. So if it's a y-intercept, x is 0. If it's an x-intercept, y is 0. And that's just an easy way of remembering which one is 0. It's the opposite one.